our new topic is linear equations. Now, a linear equation is an equation where the variable has an index or power of 1. So we never have terms like x squared, x cubed, x to the power of 4, or square root of x. The variable, which is often x, just has an index of 1. Now, to solve linear equations, we perform the same operations on both sides until the variable, or unknown, often called the pronumeral, is left by itself. Now, this will be easier to see by the way of doing some examples. So our first example, p subtract 5 equals 11. So it says up here, to solve a linear equation, perform the same operations on both sides until the variable or unknown is left by itself. So we want p by itself. So what I do, if I want p by itself, I'm just going to rewrite the question. I want p by itself. So I need to somehow remove the subtract 5 from the p. So if I add 5 to this side. Now, how did I know to add 5? I chose the inverse, or the operation of subtracting 5. So if I add 5, let's see what happens to the left-hand side. They cancel, because they give us 0. So if I add 5 to that side, I have in fact left p on its own. Let's look up here. Perform the same operations on both sides. So I can't just add 5 to one side. It's okay to add 5 to one side as long as I add it to the other. So whatever you do to the one side, you have to do to the other. It's like balancing the equation. So I've now got left on the left-hand side p, and then I do 11 plus 5, which is 16. Just do a little extra example like that. If I have something like m plus 6 equals 20, I'm wanting to get m on its own. So if I subtract 6 to that side, the opposite of adding 6, that will cancel. It does leave me the m on its own. But remember, I've subtracted 6 from one side, so I must subtract it from the other side, and 20 take 6 is 14. So what these examples are that we're doing is one-step equations, so we only have to do one thing to both sides. Let's look at another example. X divided by 16 is equal to negative 2. So x divided by 16 is equal to negative 2. So I want x on its own, and at the moment it's divided by 16. So to get x on its own, I do the opposite of dividing. Opposite of dividing is timesing. So if I times this side by 16, then I've got a 16 on the top, 16 on the bottom. They can cancel. So I've got my goal of getting the pronumeral on its own. But as we've said before, I can't just times one side by 16. It's okay to times that side by 16, but as long as I also times this side by 16. 2 16s are 32, and negative times by a positive gives us a negative. Okay, one that looks a bit harder, same principles though. X subtract 4 over 7 is equal to 5 over 6. So I'm wanting x on its own. At the moment I'm subtracting 4 over 7. How can I cancel that? By doing the opposite, by adding 4 over 7. So let's look what happens if I subtract 4 over 7 and then add 4 over 7. That cancels. Sorry, just going to remove that mess there, potentially. So subtracting 4 over 7 and adding 4 over 7 cancels, leaves me with x on the left-hand side. I added 4 over 7 to the right-hand side so that they would cancel, and that's okay as long as I add 4 over 7 to the right-hand side. Whatever I do to one side, I do to the other. So I've got x is equal to 5 over 6 plus 4 over 7. So now we're revisiting something we did earlier. We can add these together, but what do we have to do first? When we're adding fractions, we have to get a common denominator. My common denominator would be 42. Remember, I put on the top what I started with, I put that in brackets. How did you get from 6 to 42? You times it by 7, so you must times the top by 7 as well. How did you get from 7 to 42? You times by 6, so you must times the top by 6 as well. So if I multiply those out, I've got 35 on 42 plus 24 on 42. They're both over 42, so I can combine them, put them over the 142, and 35 plus 24 is 59. Yeah, so that one is a bit harder because we had to remember a previous topic. But back to the equations bit of it, whatever we do to one side, we do to the other. So that is our example of one-step equations.